Okay, so I wanted to really quick make this video because I made a mistake on the last example that we did in class yesterday, which was Thursday the 16th. So let me redo that one for you really quick so you can see the correct way to do it. Hopefully it will help you who are studying. So very quickly, let me share my screen. Okay, so this is the example. Graph this function z of x is -1/2 the square root of 3 minus x. Parent function is square root of x. 3 minus x you can think of as being the same as -x plus 3, or the opposite of x minus 3. But where I messed up is in the order which we do the transformations. And it's here in your notes. I just overlooked it. So do take note of this, the order in which to perform these, because they'll help you avoid making the same mistake that I did. So similar to what we did before, we're going to think of this as z of x equals -1/2. And maybe instead of, well, here's what I had originally. The opposite of x minus 3. It may also be helpful to distribute that minus, because as you know, these horizontal transformations in here are counterintuitive. They're typically opposite the sign that you see. And so it can get confusing what's really there. This is because of this minus out front. That's really a +3 sitting in there, even though it looks like a -3. So that's one place where you could fall into the one trap you could fall into, which is sort of what I did. So like before, let's make our chart. I'm going to use p of x for the parent function. We're going to use the same critical or the same key values 0, 1, 4, and 9. P of x being the parent function here, square root of x. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Obviously, the principal of square roots, because we're dealing with functions. Okay, so now based on the pieces of this z of x that we're trying to graph, we'll just follow we'll just look at the transformations that are going on, right? Everything that happens under the square root here is involved with the horizontal shifting, stretching, shrinking, etc. Okay, so now what we need to do, what I failed to do, is take this piece by piece. So we're going to subtract 3 because of the -3, and then we're going to change the sign of x. We're going to do it in that order because that's consistent with the notes. Again, we want to do the horizontal translation first, and then I don't know, I keep clicking the wrong thing. No, and then our stretch and shrink. So in that order. So we're going to subtract 3, remember, because it's the opposite, right? The +3 shifts to the left, so that makes the x coordinates decrease by 1. So this +3 in the translation means we're going to subtract the x coordinates by 3, and then we're going to change the sign. So write that down. All of these we're going to subtract 3, then change the sign. These y coordinates, the outputs, are what you would think, right? We're going to divide them all by 2, and then we're going to change the sign. You could do it in the other order. It doesn't really matter in this case. So we're going to divide by 2. And then change the sign. Okay, so our x values, 0 minus 3 is -3. Change the sign, you get +3. 1 minus 3 is -2. Change the sign, you get +2. 4 minus 3 is +1. Change the sign, you get -1. 9 minus 3 is +6. Change the sign, you get -6. Right now, the output values, 0 divided by 2 is 0. Change the sign, still 0. 1 divided by 2 is a half. Change the sign, you get negative 1/2. 2 divided by 2 is positive 1. Change the sign, you get negative 1. And 3 divided by 2 is 3/2. Change the sign, you get negative 3/2. So these are our new points: 3, 0, 2, negative 1/2, negative 1, negative 1, and 6, negative 3/2. So I'm just going to plot those. I'm going to plot these in red so you can kind of see them. So 3, 0 is right here. And 2, negative 1/2. I'll go over 2, down 1/2. It's right about here. Negative 1, negative 1. So that's right here. And then negative 6, 3/2. So that's 3/2 is 1.5. So I go over to negative 6, and then I go down 1.5 right here. And so now I'm connecting my points. It's going to look sort of like this. Now, as opposed to what I had before, which I had done the horizontal part wrong, so I was starting here and going out. So this is a little more correct. You can always check when you're doing homework. You can always check on Desmos, which I mentioned at the end, and you can see here what the graph looks like. Here's the original in red. Here's the transformed one in blue. So yeah, I hope that helps. You can also test some of these values just to make sure they work, like plugging them into the equation, since we have the benefit of an equation. But whatever makes the most sense for you. But yeah, the main takeaway here is the mistake that I made was doing these in the wrong order. So be aware of that.